Review for Algebra 1, Topic 8 and 9 exam, Section 1. Section 1 has 15 questions. Let's look at the first question. One thing I want to point out that I'm adding to my reviews is right here in blue, you're going to see, when applicable, what IXL section covers whatever this question is on. Okay? I did that for most of the questions. There are a few questions that are not really covered in any of the IXL sections that we did, so for those I didn't put anything. But whenever there's an IXL section that covers what's in this question, I put it here in blue so that if you want to practice it or make sure you've completed it, you can know which section to do that covers this question. All right, so let's look at question 1. It says if p of x equals x squared plus 5x minus 3 and q of x equals 2x minus 1, what is p of x minus q of x? This is a very simple problem, and this type of question comes up on the Algebra 1 EOC. It's very easy. Let me point out the only thing you got to watch out for. First, let's make sure you understand what it means. All you're doing is substituting. What is p of x? It says here p of x equals this. All right, so p of x is x squared plus 5x minus 3. All right, then you got to subtract. So let's put the minus sign. And by the way, let me put this function in parentheses. Then subtract, so minus sign. Now q of x, let me write it over here also in parentheses. It says here q of x is 2x minus 1. So make sure you understand the question because you're going to keep seeing that, especially in the Algebra 1 EOC. That's pretty simple. All right, everybody should understand how to set that up. That's not difficult. Okay, now let me tell you the only thing you need to watch out for in this question. Whenever you see this type of question, they're pretty much almost always trying to test to see if you realize that you got to distribute this subtraction sign to each term in the parentheses. The first term, nobody forgets that, but what everybody or a lot of students forget is to distribute it to the second term or to the following terms. All right, so that's what you got to watch out for. So basically, the problem is going to become this: x squared plus 5x minus 3. Now, I distribute the minus sign to the 2x, and it becomes minus 2x. But you got to remember to distribute the minus sign to this term as well, negative 1. So this negative with this negative become a positive, and it becomes positive 1. If you leave it as minus 1, guess what? If you do it as minus 1, that's going to be one of the answers here, and you're going to think you got it right, and you're going to end up getting it wrong. Trust me on that. All right, so you got to make sure that's what you always got to watch out for. Okay, now it's just a matter of combining like terms. Now, I'm going to add some lines just to make sure everybody understands how to look at this. I mean, everybody should know how to do this already, but just in case, I'm going to add these lines. All right, so this is how you should look at it. So x squared, I can only combine with another term that has x squared in the back. Nothing else does, so it's going to stay by itself. 5x, I can only combine with, oh, by the way, I got rid of this. Okay, now 5x, I can only combine with another term that has x to the first power in the back, which would be this one. So 5x minus 2x is positive 3x. And I got rid of these two terms. Okay, and the only thing left is to combine this negative 3 plus 1. Negative 3 plus 1 is negative 2. There's my answer, which means the answer is letter B. That was pretty simple. Let's look at question 2. Question 2 is same IXL, same concept. All right. Which of the following is equivalent to the expression below? So basically, we got to simplify this expression and see what does it give us. Okay. Now, again, I want to point out they're testing the same thing. Look right here at this minus sign. All right. If the people that get it wrong who actually try to do it, the reason they're going to get it wrong is because they forget to distribute that minus sign to this term, the negative 2. You got to make sure to distribute that minus sign to the negative 2, not just the 6b squared. All right, that is what you got to watch out for. Okay, anyways, so when I bring down these, when I simplify this expression, I'm going to have this, all right? So minus 6b squared And then I got to distribute the minus sign to this -2 as well, which will make it +2. And this one, when it's a plus sign outside of the parentheses, everything's going to stay the same. That's a 2 here. All right, now let's combine like terms. And again, this is not necessary, but I'm just going to add these lines to make sure everybody understands how you should think about this or look at this. Okay, so let's start with 2a squared. I can only combine it with another term that has a squared in the back. That would be this one right here. 2a squared plus 4a squared is 6a squared. And we got rid of that and that. Alright, -3b squared. I can only combine it with another term that has b squared in the back, which would be that one. -3b squared minus 6b squared is -9b squared. Let me cross those out also. Okay, now the only thing left is to add up these constants, these numbers. 7 plus 2 is 9, 9 plus 5 is 14, and there you have your answer. So the correct answer is letter D. Alright, now the next question is covered in a very important IXL. Alright, remember I was telling you guys that everything on quadratic functions is really important. And BB1 and BB2 are very important because they cover the basics that we use for everything, almost everything regarding quadratic functions. Okay, now this particular question, I have it broken down into like 3 or 4 parts because it has like 3 or 4 different questions attached to it. Alright, I have it broken down one part at a time. So let's look at it. It says, Miguel is testing how a component used in a manufacturing process responds to rapid changes in temperature over a period of 15 seconds. During this test, the temperature of the component in degrees Fahrenheit at t seconds is modeled by the quadratic function f of t equals -t squared plus 12t for t equals 0 to t equals 15. Using this model, answer the following questions. Okay, before we look at the actual questions we got to answer, let's make sure you understand what this says. Reading comprehension is super important. If you got to read it 2 or 3 times, that's fine, but you need to understand what it says. Otherwise, you can't answer the question if you don't understand what it's saying. All right, so basically this model right here is being used to test how a component used in a manufacturing process responds to rapid changes in temperature. All right, so how it responds to changes in temperature over a period of 15 seconds. Okay, during this test, the temperature of the component in degrees Fahrenheit at t seconds. All right, so look, t stands for the number of seconds. You can think about t as time. All right, so t is the time measured in seconds. For how many seconds? It says right here for a period of 15 seconds. That's why the values of t are going from t equals 0 to t equals 15, because that's the number of seconds. From 0 seconds to 15 seconds. You're inputting those values for t. 0 seconds, 1 second, 2 seconds, 3 seconds, 4 seconds, until 15 seconds. Okay, so the values of t represent time in seconds. And f of t, which is the answer that you get when you substitute those values of t, f of t represents the temperature in degrees Fahrenheit. Alright, so t is time, the time in seconds. Okay, and f of t represents the temperature in degrees Fahrenheit. Okay, remember the t in this case acts like the x, it's the domain, and f of t is basically the y. It's the answer that you get. Alright, so basically when you substitute those values for the different number of seconds and work this out, the answer that you get represents the temperature in degrees Fahrenheit. Okay, so with that in mind, let's look at our first question. The question says, what is the initial temperature of the component? Initial means at the beginning. So at the beginning of this little experiment, what is the initial temperature of the component? What is the temperature of the component? Okay, so I'm going to explain it 2 different ways. The first way I'm going to explain it is this. I've said that when you have a quadratic function, all right, A, B, and C are numbers. Okay, A, B, and C are numbers. This is A is a number in front of x to the second power. B is a number in front of x to the first power, and C is a number by itself. Okay, look at this quadratic function here. A in this case is -1. B in this case is 12, because the t to the second power and the t are functioning the same as x squared and x in this example. Okay, now what is C? C is supposed to be a number back here by itself, but there's nothing back here. What number represents nothing? Hey, I know, 0. Alright, so this number back here is always the y-intercept. And the y-intercept is always the initial point or the starting point in a quadratic function. Again, the y-intercept is always the initial point or the starting point in a quadratic function, alright? Okay, so you know what? Let me not say always. For most of these questions, the y-intercept is almost always going to be the initial point. I'm just doubting myself for 1 second. All right, but so basically, in this case, the y-intercept is 0, so the initial temperature of the component is 0. However, let me explain it a second way as well. Another way that I always explain what the y-intercept is I always say that the y-intercept is what is y when x is 0. All right? What is y going to be when the x coordinate is 0? So look back here at this example. If I put a 0 for x right here, what would be 0 times a? 0. And if I put a 0 for x right here, what would be 0 times b? 0. So the only thing left, y would have to be this number. If x equals 0, y would be whatever number is here. So that's another way to think about it. Why am I explaining it that way? Because I explained it that way here. Okay, the initial temperature of the component is what is the temperature at 0 seconds. So if I substitute a 0 right here into the function for t, I would get f of 0 equals -0 squared plus 12 times 0. Alright, again, I'm substituting 0 for t wherever you see t. So if you work that out, f of 0 equals 0. In other words, when t equals 0 seconds, f of 0 equals 0 degrees Fahrenheit. Alright, and here's my other explanation, that when a quadratic function is written in this form, that's always the y-intercept. C is the y-intercept. So in this problem, c equals 0. So basically, maybe I explained it a little bit too much, but the initial temperature is 0. Let's move on. Next part of the question. Is the temperature increasing or decreasing for the duration of the experiment? And is the temperature ever less than 0 degrees? So I got two questions here that we got to answer. So listen, here's the first thing I'm going to say, and this applies to probably, I'm going to guess, 80% of students, which is super lame. If you're just going to answer that by looking at it and saying increasing or decreasing, that's super lame. And I get super mad when people do that, all right? You cannot answer it that way. You got to work it out to see. All right. Otherwise, it's called guessing. And guess what? I could just get anybody off the street who doesn't know anything, and they could guess just as good, well, or as bad as you. All right. You need to work it out. How am I going to work this out? Well, gee, I don't know. It says we're going from 0 to 15 seconds. I don't want to do every single number because that would be a lot of work. But why don't we pick a couple different points to get an idea what happens at 0 seconds, at 5 seconds, at 10 seconds, at 15 seconds. Wouldn't that give us a good idea of how the temperature is changing? And it also would help us to not have to do not have to work this out for every single second. All right, so we already did at 0 seconds. At 0 seconds, the temperature is 0 degrees. Let's try at 5 seconds. If you substitute a 5 into the function, all right, with a calculator, this does not take that long. All right, but you do got to write it out. Okay, so at 5 seconds, the temperature is now 35 degrees Fahrenheit. Let's try at 10 seconds. Let's substitute 10 into the function. At 10 seconds, notice something. It went from 0 up to 35. Now it went down to 20. Let's try it 15 seconds. Look what happens at 15 seconds. It's at negative 45 degrees. Now I could properly answer the question after I've done some work and thought about it and work, inputted some numbers into the function to work it out and have an idea of what's happening, rather than just guess like a very lazy student, which is what a lot of students do, sadly. All right, that only takes a few seconds of work. It doesn't take that long. What, a minute at most? All right, so now we can answer this question. Is the temperature increasing or decreasing for the duration of the experiment? Well, it's doing both. It increases and then it decreases. And is the temperature ever less than 0 degrees? Yes, it is. It does get less than 0 degrees. Okay, so make sure you understand that and how to do that. And by the way, I wouldn't bother putting this stuff if you didn't need to know it for the question. All right, let's look at the next question. Whoops, sorry. 3C. It says, is the temperature the same at 0 degrees as it is at 12 degrees? Again, if you just answer that without like working anything out, you're just guessing. All right? If you're just going to guess, why are you even bothering coming to school, you know? You're going to get a diploma in guessing? All right. So yeah, like I keep saying, if you guess, that's lame. All right? How do you figure this out? Is the temperature the same at 0 degrees as it is at 12 degrees? Easy. Substitute 0 into the function and see what you get. And then substitute 12 into the function and see what you get. So let's do that. We already did 0. F of 0 equals 0 degrees. Now let's input 12 and see what we get. All right, so when you input 12 for t, substitute 12 for t in the function, you're also going to get 0 degrees. All right. Is there anything else after this? Yeah, there's one more. What is the maximum temperature reached by the component during this experiment? Okay, listen, what I'm going to do, you're going to need to know it for quite a few questions, not just one question. It's on BB2, all right? I explained it in the video for BB2, so you should definitely check it out if you haven't. And you should definitely do that IXL if you haven't, all right? So the way to find the maximum temperature reached by the component during the experiment. Okay, first of all, I don't know if you remember, well, hopefully you remember me saying this, but I said that if A is positive, the parabola opens up like that. But in this case, A is negative. If A is negative, the parabola opens down like that. So A is negative, that means that we have this situation over here on the right. The parabola opens down. If the parabola opens down, that means it has a maximum value, which is at the maximum value. You know how this is the vertex right here, and it has an x and y coordinate, vertex? The maximum value is going to be the y coordinate. Whatever y is at the vertex, that is the maximum value. All right, just like when the parabola opens up, it only has a minimum value. It can't have a maximum value because it keeps going into infinity. It keeps going up towards infinity. But it does have a minimum value, and the minimum value is the y coordinate of the vertex. So it's the same in both, except in this one, the y coordinate of the vertex is the maximum, and in this one, the y coordinate of the vertex is the minimum. But same concept. All right, so that's what we got to find. Now, how do we do that? All right, this is what I just said. Since A is negative, that means that the parabola opens downward. The maximum temperature is the y coordinate of the vertex. But we got to find it. This was in IXO section BB2. That little exclamation point is me yelling at you. All right. Okay, to find it, first, you got to find the x coordinate of the vertex by finding the axis of symmetry. To find the axis of symmetry, you need to know this formula. When you do these IXLs, you end up memorizing this formula. It's really not difficult at all. X equals negative b over 2a. All right. So in this function, you could see that a is negative 1. A is the number in front of t squared. And b is 12. So a is negative 1, b is 12. You're just substituting that into this formula. B is on the top, A is on the bottom. When you substitute that and work it out, you're going to find that the axis of symmetry is at x equals 6. And the axis of symmetry gives you the x coordinate of the vertex. All right? If you're finding this hard, it's because you haven't done this. Because if you do this, you're going to realize it's actually easy. All right, so the x coordinate of the vertex is 6, but we're not done. Now we need to plug in that x coordinate of the vertex into this function, and the answer that it gives us will be the y coordinate of the vertex, which is what we're looking for. Okay, so like I wrote here, substitute the x coordinate of the vertex into the function to find the y coordinate of the vertex. So we substitute 6 into the function, and that gives us an answer of 36 degrees. That 36 degrees is the y coordinate of the vertex. So that means that the maximum temperature reached by the component during the experiment is 36 degrees. Guys, on the exam, the function is different, the numbers are different, and I throw in a lot of different stuff to make sure that the people that are putting zero effort can't figure it out from my examples, at least for most of them. All right? For the people that do put in effort, make sure to read carefully, because I got little traps hidden in my review. For the people that are not going to listen and just like try to look at it real quick and try to just figure it out without doing any work, just looking at my review, to throw them off. All right, guys, let's continue. All right, so number 4, this one's easy. This is IXL section AA2, factor out a monomial. All right, so we got to factor out the greatest common factor in this expression. All right, there's the answer. Not even worth explaining, because you need to do this to understand it. Do this and you'll understand it. Watch my video on that where I explain this very well. All right, number 5. All right, this one's pretty easy, but let's go over it because there is 1 or 2 things I got to go over. It says last year a computer store sold 150 laptops at the price of $100 per laptop. Okay, the store manager is planning for the upcoming year. She creates the graph shown below of the projected revenue from the sales of laptop computers for next year, depending on the price increase per laptop. What does the vertex of the parabola represent in terms of the context? All right, so let's look at this, because it's easy, but the question has on the test some traps in there. All right, so first of all, understand. Let's look at this. All right, the x-axis, that does not represent the price of the laptop. It represents the price increase per laptop, okay? Make sure you read. That word is not in there just for fun. It's in there because it means something, all right? So the x-axis is the price increase per laptop. The laptop, it says here, it already cost $100 per laptop. So this is saying, for example, at 50, they're saying if I increase the price of the laptop by $50. At 100, it means if I increase the price of the laptop by $100. At 150, that means if I increase the price of the laptop by $150, making it $250. That's what that means. Make sure you understand that. And then on this side, we have the total revenue from laptop sales. All right, revenue means how much money you're making from the laptop sales. This one's pretty straightforward. All right, but this is the one I wanted to point out. So what does the vertex of the parabola, the vertex is right here. What does it represent in terms of this context? All right, let me see. The x-axis says 150. So what does that mean? How much is the laptop going to cost in this situation right here? How much does the laptop cost? And how much revenue are you going to make, or is the company going to make? The answer is the maximum revenue of $60,000 occurs when the laptops are priced at $250. Make sure you understand why it says $250, because I promise you on the test there'll be a wrong answer that'll say $150, and some of you will pick it. All right, moving on. I'm just thinking about those of you that are going to pick $150. All right, moving on. Number 6. All right, this one, there wasn't really any IXL that's specifically covered this. I mean, it's multiplying binomials, but it's more about reading the word problem and understanding it. So let's look at it. All right, it says a theater sells T tickets at a price of P dollars each. The theater conducts a survey and predicts that if the price of each ticket is changed by $3, the number of tickets sold will change by 12 tickets. All right. So look, before I continue, just look at this and look at what we just read. All right. T is the tickets and P is the price. P is price, T is tickets. All right. So the theater conducts a survey and predicts that if the price of each ticket if the price of each ticket is changed by $3, right? That is referring to this. That means like if they add $3 to the price of the ticket, or 6 or 9 or 12, because they're adding they're increasing the price of the ticket in multiples of 3. So 3 times 1, 3 times 2, 3 times 3, etc. If they increase the price of each, wait, let me say that again. That if the price of each ticket is changed by $3, the number of tickets sold will change by 12 tickets. The number of tickets sold will change by 12 tickets. All right? So here it says if n is the number of times the theater changes the ticket price. Excuse me. If n is the number of times the theater changes the ticket price by $3, this expression can represent the theater's total revenue in dollars. So n is the number of times that they change the ticket price by $3. So if they change it once, twice, 3 times, etc. So the number of times they increase it by $3, notice that the number of tickets sold go down by 12 each time they increase it by 3. All right. Listen, this is the type of thing you got to read it slowly and it'll make sense. All right. So it says here in this expression, what does t minus 12n represent? Now read each answer carefully. All right. It's not A, because A says the number of tickets the theater will sell if the ticket price is decreased by $12. No. Okay, first of all, is the ticket price being changed by $12? No, that's the number of tickets sold. The price of each ticket is changed by $3. All right, by $3. It says it right there. So that automatically eliminates answers A and B here, because they're talking about the ticket price changing by $12. It can't be A or B. It's got to be between C or D, because they're talking about the ticket price being increased by $3. The correct answer is D. All right. T minus 12n represents the number of tickets the theater will sell if the ticket price is increased by 3n. N represents the number of times they increase the price by $3. All right. Make sure you read it slowly and understand it. Don't wait till the day of the test to try to understand it, because you're going to be stressed out and have a hard time understanding it. All right, next one. All right, for the next question, this is not the question. This is me. I'm going to give you a quick explanation on the n behavior of a polynomial function. This is something that we have not gone over in my intensive math class. I assume you've gone over it in Algebra 1. But even if you haven't, guess what? I'm going to go over it right now. So no excuses. All right. I'm going to treat it like you've never heard of this before, okay? First of all, n behavior. The n behavior, let me change the color of my pen so I can show you what I'm talking about. The n behavior is talking about this, the ends of the graph. How are they behaving? Where are they going? All right, this part here, this part here, this part here, and this part here. Where are they going? Okay, that's what the n behavior is referring to. Okay, so when you first look at this, and by the way, let me tell you something. I just put this together, finished putting together this review like a little while ago, and I hadn't done this in like a couple years, and so I could see it through your eyes. If you're looking at this and you're like, huh? Because I felt like that it took me a couple minutes to remember. I knew there was a way to remember this, and it took me a couple minutes to refresh my memory and remember how to memorize this, because it's really not difficult. I'm gonna show you how. All right. Okay, so where do I start? Let's start right here with degree. All right, the degree is talking about, remember that there was an IXL where the degree of a polynomial is the highest exponent in that polynomial. So like in these two, the degree is 2 because the biggest exponent is the number 2. And over here in these, the degree is 3 because the biggest exponent in these polynomials is 3. Okay, so that's what the degree is referring to. If the degree is even, if the degree is an even number, notice that the ends of the graph are going in the same direction. So that's the first way to remember. If the degree is even, the ends of the graph are going in the same direction, either both up or both down. Whereas if the degree is odd, like in this case it's an odd number, the number 3, then they're not going in the same direction. One is going down and one is going up. One is going down and one is going up. Alright, so again, if the degree is even, if the degree of the polynomial function is even, the arrows are going in the same direction, either both up or both down. And if the degree is odd, one of them is going up and the other one is going down. And same thing here. Okay, that's step 1. There's only one more thing to remember. The next thing to remember is if the degree is even, if the leading coefficient, I was trying to remember what the next part was. If the leading coefficient is positive, okay, what's the leading coefficient here? The leading coefficient is the number in front of x squared, which is positive 1. Okay, if the leading coefficient is positive, they both go up. If the leading coefficient is negative, like in this one it's negative 1, they both go down. And I'm gonna do the same concept over here, okay? If the leading coefficient is positive, right? Like in this one, the leading coefficient is positive 1, then from left to right, it's going up. Like think about it, from left to right, it's going up. You read from left to right. All right, so from left to right, this line is going up. All right, and over here is going down. And if the leading coefficient is negative, then from left to right, it's going down like that. Okay. Do you have to have all this? Do you have to know all this for this test? No, you don't. At least not for section 1. I haven't looked at section 2 yet, so I may update that later. But for section 1, you don't need to know all this. But it is on the Algebra 1 EOC. And by the way, this part right here, you should understand how to read as well. It's not difficult. I'm pretty sure I've gone over it early in the year, but let me go over it again. The only thing I don't like is I prefer to look at it starting with the x part. Okay, as x approaches negative infinity, that's this way to the left. That means as the x coordinate approaches the negative, let me say that better. As the x coordinate gets more and more negative, it's approaching negative infinity this way. F of x, which is y, is approaching positive infinity this way. And as x approaches positive infinity, which is this way, f of x, which is y, is approaching positive infinity. Okay, you know what? I could spend more time on this, and I probably will in the future, but for the sake of this test, we don't need to go over all this that much. So let me go to the actual question. I just wanted to give you a quick refresher on that and tell you how I would always tell students to memorize this. All right? Okay, so look, here's the question. What would a sketch of the polynomial function, all right, they give us this function, look like? Okay, so on the test, you're going to have 4 different graphs to choose from. So let me go over how to do this. Before I show you my graph, let me show you something, all right? If I multiply all this together, right, like if I distribute the x to everything here, let me do that a second to show you something. All right, so if I multiply x times x minus 4, I'm going to get x squared minus 4x, right? And then if I multiply that times x plus 3 to further simplify this, and the way you multiply that is the first term times each of these terms, and then the second term times each of these terms. If I do that, I'm going to get x to the third power plus 3x squared minus 4x squared minus 12x. Alright, that was my writing tool, sorry about that. And I got to combine these two right here. So my final answer will be x to the third power. 3 minus 4 is negative 1. So negative x squared minus 12x. Okay, now why did I do that? Okay, let's talk about the end behavior. What's the degree of this polynomial function? The degree is 3, which is odd. Alright, that means that the graph is either going to be, you know, whatever here, something like that, or something like, like that. In the middle, we don't know what's going to happen. I'm just talking about the end behavior, okay? When it's odd, it's either one down and one up, or one up and one down, all right? Then the next question was, what's the leading coefficient? Is the leading coefficient positive or negative? The leading coefficient is positive 1. If it's positive, that means that from left to right, it's going up like that. So that means that the sketch of the graph is going to look something like this. In the middle, I don't know what's going to happen, but the end behavior is going to look like that. All right. Now that I established that, let's look at the graph and I'll explain the other part. Here's the graph. Okay, look at the end behavior. It's what I said. All right, this part is down and this part is up, and in the middle there's some other stuff happening. Let's talk about the middle. Okay, you got to make sure you know how to find the zeros, which are also called the roots of the function. We did an IXL on that. You know what? I forgot to put it here. It's the IXL on zero product property. I forgot to write that here, but it's the IXL that's on zero product property. All right, it's BB something. I think it was BB7. I'm pretty sure it's BB7. Anyways, okay, you got to find the zeros, which are also called the roots. And in fact, on some of the questions, they refer to them as the roots. The roots means the zeros of the function. All right, to find them, all you got to do is... Did I do it here? No, I didn't. All right. All right, to find them, all you got to do is set each factor. This is a factor, this is a factor, and this is a factor. Set each factor equal to 0. When I set x equal to 0, I get that. When I set x minus 4 equal to 0, I get that. And when I set x plus 3 equal to 0, I get that. Now solve for x in each situation. All right, this situation, x is already by itself, so it's done. In this one, I got to move 4 to the right, so x will equal positive 4. And in this one, I got to move 3 to the right, and it becomes negative. So x equals negative 3. Those are the roots or the zeros of this polynomial function. You see these 3 dots? That's where they got to be at. At x equals 0, which is right there. At x equals negative 3, which is right there. And at x equals positive 4, which is right there. That's super easy. IXL BB7, if you haven't done it. All right, that's all it's on. Okay, so... the zeros are located at these spots, so you got to make sure that the graph of this polynomial function is passing the x-axis at each one of those points. That's very simple. All right, and the other thing is the end behavior, which I explained here. As x is approaching negative infinity, that means as the x coordinate is approaching negative infinity this way, f of x is approaching negative infinity. All right, that means if you don't get that, that means that if I were to keep putting the coordinates here, all right, I'm trying to move more to the left. The x coordinate is getting more negative, and so is the y coordinate. As x approaches negative infinity, f of x is also getting more negative, approaching negative infinity. And on the other side, as x approaches positive infinity, all right, as x is getting more and more positive, 4, 5, 6, 7, 8, 9, 10, a million, 2 million, whatever. All right. F of x, which is the y, is also approaching positive infinity. It's also growing bigger and bigger in a positive direction. That's what that means. You got to understand how to read that. These questions come up big time on the Algebra 1 EOC, especially this. They're going to give you an Algebra 1 EOC, fill in the blanks. Not multiple choice, but fill in the blanks. Well, they'll just give you this and be like, what are the zeros of this function? Or what are the roots of this function? This is so easy to answer. And yet a bunch of you will be like, huh? Don't be like those people. Those people are weak. They're an embarrassment. Don't embarrass me. All right, let's move on. Here we go, same concept. And by the way, on this one, I did put it. I should have put it on the last one. It's BB7. All right. If I get a chance, I'll fix it for the PowerPoint for when I put it on Teams. All right, but it's BB7. All right, listen, this is the same question, except here we have variables, but it's the same exact concept, all right? It's going to look all weird to you at first, all right? You got to calm down, take a deep breath, and realize that if you just read it slowly, you got this. The question is, what are the roots, aka the zeros, of this quadratic equation? Again, I'm going to say it again. On the test, they use both terms In some questions, they say the zeros. In other questions, they say the roots. They're both referring to the same thing. Now, how did I do it in this previous question? Do you remember how I did it in this previous question? Set each factor equal to 0 and solve for x. Guess what? That's the same thing you got to do here. It looks weird. Big deal. Do the same thing. I have one factor here and I have another factor here. Those are two factors. Set each one equal to 0. All right, so there I go. Here's this factor equal to 0. Set, I put it equal to 0. And this factor equal to 0. That's not hard. Now, solve for x, kids. So first thing you do is move the b to the right in this one and move the d to the right in this one. And you got that. Now, let's get rid of the a and get rid of the c by moving them to the other side and dividing. Hey, what do you know? We're done. That's it. That's all you had to do. Those are the roots of this quadratic equation are at x equals negative b over a and at x equals negative d over c. That is on the test, and that is easy. You just got to be able to know how to read that and be confident and not be weak. All right, question number 9. All right, listen, I got to tell you something. I'm still learning. One thing I'm working on is getting better at making graphs using the whatever the software I have, and it's actually a little bit challenging. I haven't really had time to really get good at it. Get good at it yet. I know how to do it, but I'm still not good at it. And I was pressed for time, so I just had to do this little drawing. It's kind of a mix of I did this part with one thing, and then I drew the rest. All right, but it should work. All right. All right, so here's the question. The graph shows a function that represents the weekly earnings in dollars for a company that makes X sets of headphones per week. Based on the graph, answer the following questions. All right, so before I look at it's going to have several questions. First of all, let's make sure we understand this graph. This is for the x-axis is the number of headphones made per week. So right here, we're at 3,000 headphones per week. It should be obvious that each one of these little these hash marks is 1,000. This is 1,000, 2,000, 3,000, 4,000, 5,000, 6,000. And here are the earnings. How much money you're making. $1,000, $2,000, $3,000, etc. Okay? Here's our vertex. And by the way, this is not too clear, but the vertex is right here. It's supposed to line up with 5,000 here and 3,000 here, okay? In case it's not clear from my little drawing. All right, so first question. When producing 6,000 headphones per week, what are the weekly earnings? So when we're right here, we're producing 6,000 headphones per week. Look to the left, to the y-axis. What are the weekly earnings? That should be $0, kids. Next question. How many headphones per week must be produced to achieve the maximum amount of weekly earnings? The maximum amount is right here. How many headphones do I got to produce each week to produce the maximum amount? That would be 3,000. Next question. What is the maximum possible earning per week? All right, that would be right here where you're earning $5,000. Pretty simple. And last question, I believe, or no, there's two more questions. Okay, listen, make sure you pay attention. If production is increased from 1,000 to 2,000 headphones per week, do the weekly earnings increase or decrease? So if we're at here's 1,000 headphones per week. If we increase that to 2,000, look up here. Look at our graph. Okay, do the weekly earnings increase or decrease? That looks to me like it's increasing. Yep, increase. Okay, last question. If the production is increased from 4,000 to 5,000 headphones per week, that's over here. 4,000 to 5,000. Let's look at that graph right here. If it's increased from 4,000 to 5,000 headphones per week, are the earnings increasing or decreasing here? I don't know. I don't think you have to be an expert at math to understand what that means. Looks to me like it's going down. Decrease. All right, moving on. Question number 10. Which of the following functions have the same y-intercept as the function below? Select all that apply. This has several correct answers, and it has quite a few traps. It has quite a few traps that I'm going to point out to you. I'm imitating the same traps that are on the exam, so please listen to me so that you don't make the same mistakes. All right. First of all, what is the y-intercept here? You should already know. It should be automatic. All right. The y-intercept is always this number right here when you have a quadratic function written in this form. All right, it's always the number here because remember that the y-intercept is what y is when x equals 0, and if you substitute a 0 into this function, which is not necessary because I already told you how to analyze it really fast, like a boss. All right, but when you substitute a 0 into the function, this is going to cancel out and this is going to cancel out. So the answer is always going to be the number that's back here, which that'll be the y-intercept. When x equals 0, the y-intercept is always this number. All right. With that in mind, that means that our correct answers are all the answers that have a y-intercept of 16. So let's look at it and I'll point out the traps. Letter A, that one's easy because it's written in the same form as this one. Letter A has a y-intercept of 12, so therefore it's wrong. That's not what I'm looking for. Letter B is also written in this form and it has a y-intercept of 16. So letter B is correct. That's a good one. That's correct. All right, let's look at letter C. Okay, letter C, let's work it out so that we can know for sure what the y-intercept is. Let's work it out. How do we work that out? By multiplying x minus 9 times x minus 1. All right, you multiply x times x, you get x squared. X times negative 1, you get negative x. Negative 9 times x, you get negative 9x. And negative 9 times negative 1 is positive 9. Now let's combine these two like terms in the middle. So you're going to get x squared minus 10x plus 9. Here's my y-intercept. Does that say 16? Nope. So therefore C is wrong. So far A and C are wrong and B is correct. Okay, let's look at D. All right, again, let's work it out. Although I'll give you a shortcut. When they're written like this, you could just multiply these two numbers and that'll tell you what I'm going to get for the y-intercept. All right, so if you're paying attention, that means that, yeah, this one's going to be right. But let me work it out just so you can see what I mean. All right, x times x is x squared. X times negative 2 is negative 2x. Negative 8 times x is negative 8x. And negative 8 times negative 2 is positive 16. I got to combine these two, but whatever. There's our positive 16. So D is correct. All right, so far B and D are correct. B is right. D is right. Okay. I messed up. I messed up because I wanted to set. Hold on. All right, whatever. I'm not gonna fix it now, but okay. Okay, let's look at E. All right, let's look at E a second. E has this. I'll tell you what I think I forgot to put in a second. All right, but E has this. Right. Listen, before we answer the question, why don't we work this out to see if this changes this number that's right here? X minus 1 to the second power means this. X minus 1 times x minus 1. Let's multiply that and see what we get. X times x is x squared. X times negative 1 is negative x. Negative 1 times x is negative x. And negative 1 times negative 1 is positive 1. Alright, now combine these terms in the middle. You got x squared minus 2x plus 1. Okay, now I didn't bring this down. Let me bring this down. You had this back here. And you had this back here. So basically, when we work out that part, we end up getting this right here, 1 plus 15. That's going to give us 16 by itself. That's the y-intercept. So E is correct. E gives us, when you work it out, you're going to get a 16 back here. All right, so B, D, and E are correct. Okay, F is wrong, but I kind of messed up what I wanted to imitate. F is wrong. Trust me, if you work it out, it's wrong. But what I wanted to imitate is, I think on the test it has something like this. Let me put letter G. Wait, hold on. This will be option G, which is wrong, and I just want to show you to make sure you don't fall for this trap. If I put this like that, all right, don't just be like, golly gee, mister, there it is, 16. Because when you work this part out, you're going to get another number that you got to combine with the 16 that's going to change it. So 16 is not the y-intercept. So make sure, I think I meant to put that there and I got confused. Sometimes I try to mix it up so much I end up confusing myself. All right, but I meant to put this trap because I think it's on the test. All right, so again, be careful. All right, yes, that has a 16, but when you work out this part, it's going to give you a number that you can combine with 16 that's going to change the 16. So that's not the y-intercept. All right, let's move on. So for this example, those are the correct answers. All right, now I'm going to go over something that we did not cover in my class. You covered it, or you should, I assume you covered it in your Algebra 1 class. It's about polynomials and closure. In section 1, there's a question about this that I'm going to set you up to get it right. But first, let's make sure you understand what this means. All right, I should have put this sentence first. Let's look at this sentence right here first. Closure means that when you do the operation, when you do an operation like addition, subtraction, or multiplication, the operation produces another polynomial. All right, so polynomials are closed under the operations of addition, subtraction, and multiplication because when I add polynomials or subtract them or multiply them, I get another polynomial. But when I divide them, I don't always get another polynomial. That's what they mean by closure. All right. So again, polynomials are closed under the operations of addition, subtraction, and multiplication. Right here, I put 3 examples in green that show, hey, I add polynomials and I get a polynomial. I subtract polynomials and my result is another polynomial. I multiply polynomials and my answer is a polynomial. But for division, it's not closed because you could divide 2 polynomials and get an answer that is not a polynomial. Why is this not a polynomial? This is important because it's on the question that I'm about to go over. Negative exponents are not allowed in polynomials. Negative exponents are not allowed in polynomials. All right, so polynomials are not closed under the operation of division. All right, negative exponents are not allowed in polynomials. Therefore, polynomials are not closed under division. All right, so let's look at the actual question here. Shout out to Amanda. Put her in the question. All right, so it says Amanda is demonstrating the idea that polynomials are closed under addition. Select an equation or phrase to complete the sentence. All right, so I'm imitating what's on your test, okay? So part A says she adds, and it has like some polynomial here, and then it has like, she's adding that to, and there's a blank, and you got to choose one of these equations to put into this blank. How do you answer this? Very simple. If you look at the, honestly, even without understanding it, you can look at the 3 choices and ask yourself, which one of these choices is not like the other 2? All right, so if you look at them long enough, you'll realize that these 2, choice A and choice B, have negative exponents, and choice C does not have any negative exponents. Whoops, what did I do? Sorry about that. All right, choice C does not have any negative exponents. All right, so I think I forgot to put the answer in this one. Choice C does not have any negative exponents, so you got to choose the polynomial expression that does not have any negative exponents. All right, that's easy to remember. And then part B, you got to choose, like, I underline the answers, to be honest with you, because honestly, it's kind of hard to imitate this and explain it without just giving you the answer. All right. So those of you, the people that are like logged in and sleeping right now, they'll never know. All right, but if you're paying attention, all right, it's gonna, these 2 fill in the blanks. Those are basically the answers. All right, this is closed because the exponents of the sum are whole numbers, and the sum is a polynomial. I'm not a big fan of this question, but it's on your test. All right, so and I forgot to put the answer. So if I get a chance, hopefully I'll remember to circle C. Otherwise, if you guys look at this PowerPoint later, you're gonna be like, huh? All right, we're almost done. All right, number 12. A firework is shot into the air, but it malfunctions and does not explode. The firework's height below or above sea level in meters, h, as a function of the time. Hold on. The firework's height is h, right? The firework's height below or above sea level in meters, h, as a function of the time in seconds, t, since it was shot, is this quadratic function here, is modeling that situation. The question is, what is the maximum height of the firework? All right. So listen, I can't emphasize enough how important it is to understand how to do these questions, because they're big time on the Algebra 1 EOC, and they're on this test several times. Where is this from? Hello, I keep telling you guys, make sure to do these. If you do these, you'll learn in baby steps, and it'll actually make sense. And after this test, we're going to go over more stuff that goes even deeper into quadratic functions, and they get hard. So how am I going to teach you that if you don't understand the easy parts? And these are the easy parts. All right? I'm telling you, these are the type of questions that look difficult, but all it takes is a little bit of understanding, and they're actually easy to solve. But you got to be willing to learn. All right? So let's make sure you understand this quadratic function a second. T is the domain, the values that you're putting into the function. T stands for time in seconds. All right, so what you're inputting is like, at 0 seconds, where's the firework? At 10 seconds, where's the firework? At 60 seconds, whatever. All right, and h of t, the answer that you're getting is the height of the firework below or above sea level. So h of t, the answer that you get when you plug in different values for time, the answer that you get represents the height of the firework above or below sea level. If it's a positive number, that means it's above sea level. And if it's a negative number, that means it's below sea level. All right, now that we got that out of the way, a firework is shot into the air. Okay, remember that I said if A is positive, the parabola opens up, and if A is negative, the parabola opens down. What's A, positive or negative? A is right there. It's negative. So that means that since A is negative, the parabola is going to open down, which makes sense. We're firing a firework into the air. It would make sense that the parabola is going to look like that, not like a U. All right? So the question is, what is the maximum height of the firework? We already had questions like that. How do you figure that out? Okay? How do you figure out what is the maximum height? Hold on, let me draw that better. If I were to do a sketch of this is the firework. What do you think is going to be on this axis? The domain is the values that you're inputting for t, which is the time in seconds. Okay? And the answer, by the way, this is t. The answer that you get, the h of t, is the height of the firework. All right. Now, how do you find the maximum height of the firework? Easy. You got to find the vertex. Now, how do you find the vertex? All right. First thing you got to do is find the x-coordinate of the vertex, which is the axis of symmetry. You got to use this formula. I do it like a million times in this IXL. If you look at the video and do this IXL, which is not difficult, you'd have it memorized. All right. So, all right, here I got the solution. First, identify A, B, and C. What values are they? All right. Next, since A is negative, that means the parabola opens down. The vertex will be at the highest point of the parabola, and the y-coordinate of the vertex is the maximum value of the function. Next, find the x-coordinate of the vertex by finding the axis of symmetry, which is what I was just talking about. How do you find it? By using this formula, x equals negative b over 2a. Substitute the values for b and a, work it out, and that is the that is the x-coordinate of the vertex. All right, that means at 4 seconds the firework will be at its maximum height. But I need to know what height that is, so I gotta plug in that 4 into the function. When I plug in the 4 into the function. I should have put h of 4 here and I didn't. H of 4 equals, all right, I'm plugging in a 4 wherever you see t. When you work it out, you get 6. Is 6 positive or negative? I know, stupid question, but why am I asking it? Because if it's positive, that means above sea level, and if it's negative, that means below sea level. So the answer here is 6 meters above sea level. Is it the same numbers on the test? Heck no. I changed them. You're going to have to work it out. Alright, so make sure you know how to do it. Next question. Number 13. Okay, and number 13, we did an IXL on that. BB4. Transformations of quadratic functions. The question is, how is the graph of g of x equals negative x squared plus 2 related to the graph of f of x equals x squared? Remember that I've gone over this and I said this is the parent function. Alright? If you add a number back here to it, it moves it up or down. And that's what this is doing. It's moving it 2 units up. And if you put a negative sign here, it's reflecting it over the x-axis. Alright, listen, I can talk about this a lot, but really, if you don't get that, you need to look at my video for BB4, where I go over it in detail and do like a million examples. In fact, I've probably over-explained many questions on this review. I should have just said, you know what, just go to my video on BB whatever. Alright, number 14. This one's easy, or it should be easy. It's on this IXL Z4. It says a triangle. A triangle, kids. It always helps to draw a picture. You can visualize whatever they're talking about. A triangle has side lengths of 6a plus 2. I misspelled inches. 6a plus 2. Sorry about that misspelling. And 4a plus 5. If the perimeter of the triangle, how do you get the perimeter? By adding up all the sides. If the perimeter of the triangle is this much, what is the length of the third side of the triangle? Alright, so when you add up these 3 sides, you get this. How do you figure out what this side is? Alright, so the perimeter is the distance around the outside of the figure. So right here I got the first side that they gave me. Right here I got the second side that they gave me. And then I just put right there the letter X to represent the third side. When I add all of them up, I'm supposed to get this. Okay? So, set up your equation like that and solve for X. That's my answer. X equals 7a plus 3. Alright, just look at how I worked it out. I'm just combining like terms and getting X by itself. Alright, that should be easy. Just look at it, look at it slowly and you'll understand it. You should understand it. But that's on the test. Again, with different numbers, different letters, whatever. I mix it. Okay, question 15. Question 15, it says the graph of the function f of x is shown in red and the graph of the transformed function g of x equals f of ax plus k is shown in blue. What are the values of a and k? Alright, and out of everything in section 1, this is the hardest one to explain. Alright, so this one definitely requires you to pay attention. Alright, so I'm going to try my best to explain it. Let me do it first by going over the parent function, which I've mentioned many times before. Okay, the parent function is x to the second power. And I'm going to use h of x because f of x is already in the problem. And I don't want to cause any confusion, alright? But the parent function is when you have just the x to the second power. And what does the parent function look like? Okay, let me put a couple random values for x so that I could plot the points on the graph and use it to compare it to the other functions and help me to figure out the other functions, alright? So if I put some random values for x like these, then when x is negative 2, h of x is positive 4. When x is negative 1, h of x is positive 1. When x is 0, h of x is 0. When x is 1, h of x is 1. When x is 2, h of x is 4. So if I plot those points, I'm going to have this. And it keeps going, but I'm just going to use those points as a reference for now. Okay, so first of all, let's compare the parent function to let's compare h of x, which is the parent function in my example, to the red line f of x. Okay, so if you look at the points on the parent function, okay, like for example, let's look at this point right here, 1, 1. If we start at the vertex and go 1 unit to the right and 1 unit up, we have a point, right? Now look at the f of x, the red line. Okay, if I start at the vertex as well and go to the right 1 unit and up 1 unit, right there's a point as well. And same thing on the left side. Okay, now let's go back to the pink one, h of x, the parent function. If I go 2 units to the right and 4 units up, I have a dot there. Same thing to the left, 2 units left and 4 units up, I have a dot there. Now if I do the same thing starting from the vertex of f of x, the red function, 2 to the right and 4 up, you'll notice that there's a dot there, and 2 to the left and 4 up, you'll notice there's a dot there. Okay, what does that tell me? That tells me that the red line, f of x, is the parent function just moved up 1 unit. The parent function moved up 1 unit. How do I write that? Like this. I'm sorry, not g of x, f of x. Okay, it's the parent function moved up, everything moved up 1 unit. Alright, remember if you write a number back here, that moves it up or down. Alright, so this is the equation for f of x. Okay, now let me show you how to get the equation for the blue line, alright, which is g of x. This one's going to be a little bit more work, alright? So for g of x, okay, first of all, if we compare the blue line to the parent function, which had its vertex at 0, 0, it's been moved up 5 units. Okay, so the equation for g of x is going to be something x to the second power plus 5. Okay, that something is a. I got to figure out what number is a because that's one of the questions. I'll get to what's a and what's k in a second, but basically there's a number that they're multiplying here everything by, and that's this a that's right here. Okay, so I'll say it again because again this one's a little difficult for me to explain, which is rare for me, but alright, so compared to the parent function, the blue line has been moved up 5 units. So that's how I got this. Okay, now let me make a table of values for g of x, okay, and that'll help me figure out what number goes here. Alright, so here's x and here's g of x, okay, so let's use the same numbers that I always use. Alright, let's start with 0, okay. If I put 0 into this function, I'm sorry, if I put 0 when x is 0, I'm sorry, when x is 0, what is y? When x is 0, y is 5. Alright, when x is 1, what is y on the blue line? Alright, when x is 1, y is 8. Alright, same thing on the other side. When x is negative 1, y is 8. How about when x is 2? When x is 2, y is, it's hard to tell, I know, but it's this right here. It's 17. And when x is negative 2, again, it's hard to tell, but I can tell a little easier because I'm recording this and I and I have my face real close to my computer. But when x equals negative 2 or positive 2, g of x is going to equal 17, okay? With this table of values, I could figure out what number goes here. This is how I'm going to do it. So look at, like for example, look at this. Let's say we take x equals 2, all right? Let's say I take 2 and plug it in here, all right? So when x equals 2, I'm going to write this part out. Instead of writing ax squared plus 5, All right, let's write a. I said when x equals 2, so a times 2 squared plus 5, that has to equal 17. So if you solve this equation for a by subtracting 5, I don't have much space, so I'm going to like speak it out. Subtract 5, you'll get 12. By the way, you know what? Let me work this out. 2 squared is 4. So this will be 4a. If I write it like this, it's easier to see. 4a plus 5 equals 17. So when you move 5 to the right and subtract it, and then divide by 4, you're going to get a equals 3. If you want to test out if you're correct, again, I got a equals 3. Let's test it out with this one as well. If I plug in a 1 into this function, all right, so g of 1, sorry, my writing tool is messing up right now at the last problem. G of 1 equals a times 1 to the second power plus 5. And when x equals 1, I'm supposed to get 8. So 1 to the second power is 1. So this will be 1a plus 5 equals 8. All right, so when you subtract by 5 and divide by 1, you're going to get, again, a equals 3. All right, so basically the equation for g of x in this case, sorry guys, my writing tool is big time messing up all of a sudden, is going to be 3x squared plus 5. That's the equation, right, for the blue line. 3x squared plus 5. Okay, now let me show you how to go from that to the answer. Let me erase all this because okay, so once again, f of x, the equation for f of x is x squared plus 1, and the equation for g of x is 3x squared plus 5. All right, now look at the question. What are the values of a and k? All right, k compared to, if you compare these two, the way they're written, k is what do you add to this function to move it up? How many units are you moving up this function? You're moving it up 4 units. You moved it up 4 units. Here it says plus 1, here it says plus 4. It moved up 4 units, so k equals 4. And then a is what are you multiplying x squared by? This here you have a 1, and here you have a 3. So you're multiplying everything by 3. A equals 3. Listen, this problem is a little difficult. It wasn't my smoothest explanation, but I can't think of a smoother way to explain it right now. So that's going to have to do for the explanation, all right? This is one that you definitely want to look at before the exam because this is on the exam and the numbers are different. The graphs, I made these graphs so that they'll be different from the ones on the test. All right, but if you use my method, you could get the answer right on the test just doing what I did. But yeah, this one, out of all the ones on section 1, this was the only one that was a little bit tough to explain. And I'm guessing a lot of you guys, you'll probably have to look at it again one or two more times on the video to fully understand it and maybe try to work it out as well. All right, guys, that's it for section 1, guys. Next class, we'll do section 2, and then the section after that, you'll have the rest of your Algebra 1 exam, section 2 of your Algebra 1 exam. Have a great day. I'll see you guys next class.